Hello, hello. Here is the Unit 6 Quadratics in Standard Form portion of your second semester final exam review packet. So quadratics in standard form, we start by looking at classifying polynomials based off of their degree and the number of terms that they have. So if you look at the table that's presented to you, your degree, when you name it, it can either be a constant, linear, quadratic, cubic, etc. If there's one term, it's a monomial, binomial, trinomial, or polynomial if there's four or more terms. So number 24 says to classify the polynomial by degree and the number of terms. So your degree is your highest exponent. So right here, my degree is 2. So if I look at my little table over here, anything with a degree of 2 is going to be a quadratic. So this is a quadratic. And I'm also going to count the number of terms that I have in this expression. I have 1, 2, 3 terms. So when I have 3 terms, that is going to be called a trinomial. So this is a quadratic trinomial. Okay. Number 25, which of the following will simplify to a quadratic binomial? So a quadratic means my degree is going to have 2, which means I'm going to have an x squared. And a binomial means I'm going to have 2 terms in the final result. So for all of these expressions, I do need to simplify them. So for letter A, I'm adding my like terms together. I don't have any other x squares, so I have x squared. I'm just going to write it in standard form so it's in order. So x squared plus 1x, negative 2 plus negative 1 is negative 3. And this is a quadratic, but I have 3 terms, so it is not a binomial. So this right here is not going to be one of your answer choices. For letter B, if I look and start to combine like terms, x cubed minus 3x cubed is going to give you negative 2x cubed. And I'm actually not even going to finish simplifying this because I see right away that I'm going to have an x cubed. And that is going to be a cubic instead of a quadratic. So again, letter B, not your answer. For letter C, I'm going to go ahead and multiply it out. I do need some space for this, so I'm writing it at the bottom. I'm going to go ahead and distribute. You can also multiply using the box method if that's your preferred method. But 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. 1 times 2x is 2x. 1 times negative 1 is negative 1. And I can combine my like terms in the middle. They actually end up canceling out because negative 2 plus 2 is 0. So that leaves me with 4x squared minus 1. Which just so happens to be a quadratic binomial. Quadratic because I have the x squared, and binomial because I have 2 terms. So my answer for this question is letter C. Number 26, which expression is equivalent to this? I don't feel like reading it all out loud. So what I'm going to do is, since I have a subtraction question, I'm going to go ahead and start rewriting. So I'm going to distribute the minus first. I'm going to rewrite x cubed plus x squared plus 4x minus x squared. Negative times negative 5x gives me positive 5x. Negative times 6 is negative 6. And I'm going to start to look for my like terms. I don't have any other x cubed, so I'm just going to rewrite that. I have x squared minus x squared. That's going to cancel. 4x plus 5x is 9x and minus 6. So looking at my answer choices, that is letter G. 27, anytime you see something in front of the parentheses, your gut should tell you, hey, I should distribute. So I'm going to go ahead and distribute. 2 times 3 is 6. X times x squared is x cubed. 2 times negative 2 is negative 4. X times x is x squared. And 2x times negative 1 is negative 2x. So looking at my answer choices, it is letter J. All right, 28. Find the perimeter and the area. For the perimeter, you're going to add all the sides together. And area of a rectangle is going to be length times width. So since I want to add all my sides together, I'm actually going to go ahead and rewrite all of my sides. I have 2 out of the 4 sides. I have x plus 4 on one side, go straight across, that's also x plus 4. X squared plus 3, go straight across, and that's also x squared plus 3. So to find the perimeter, I want to add all those sides together. So x plus 4 plus x squared plus 3 plus x plus 4 plus another x squared plus 3. And then I can combine all of my like terms. So x squared plus x squared is 2x squared. X plus x is 2x. And finally, 4 plus 3 is 7, plus 4 is 11, plus 3 is 14. So your perimeter is 2x squared plus 2x plus 14. For the area, I need to multiply my length times width. So that is going to be x squared plus 3 times x plus 4. This one I'm actually going to multiply using the box method just to show you a different method. Or if this is your preferred method, then you can see it being done. So I have x squared plus 3, x plus 4. And I'm just going to multiply the sides of my box together. So x squared times x is x cubed. X times 3 is 3x. 4 times x squared is 4x squared. 4 times 3 is 12. As I'm taking out the terms from my box, I do want to write it in order. So x cubed first. I do not have any like terms to combine, so I can just rewrite it. So 3x plus 12. I'm going to circle this one because it ended up being too close to the 4. There we go. And since I circled that answer, I might as well circle the perimeter because then it just looks weird. All right, next question. Simplify each expression. So x minus 5 squared is the same thing as x minus 5 times another x minus 5, and you distribute or use the box, whatever floats your boat. X times x is x squared. Negative 5 times x is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is positive 25. I chose to stack my terms, and then I'm just combining them. So x squared minus 10x plus 25 is your final answer for 29. For 30, go ahead and use the box to add some variety. 3x minus 4, 2x plus 5. 2x times 3x is 6x squared. 2x times negative 4 is negative 8x. 5 times 3x is 15x. 5 times negative 4 is negative 20. Got my like terms right here, which I'm going to combine as I rewrite my expression. So I have 6x squared, 15x minus 8x is 7x minus 20. And voila, there is number 30. For 31, you can distribute or use the box, but you do have a binomial times a trinomial, so just be careful. Distributing the 2x, so 2x times x squared is 2x cubed. 2x times 7x is 14x squared. 2x times negative 10 is negative 20x. Negative 1 times x squared is negative 1x squared. Negative 1 times 7 is 7x. Negative 1 times negative 10 is positive 10. And combining like terms, that gives me 2x cubed. 14x squared minus 1x squared is 13x squared. Negative 20x plus 7x is negative 13x plus 10. Just keep track of your terms and keep track of your positives and negatives for that as well. 32, convert this vertex form into standard form. I'm actually going to start by rewriting this expression to x minus 3 times x minus 3 plus 1. I'm going to go ahead and work through that distribution first. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And I can just bring down that plus 1 and combine your like terms. So I have x squared minus 6x plus 10. And that equals y, since we want it in standard form. All right, 33. Match each quadratic with the correct form. Letter A is vertex form. Letter B is factored form. And letter C is standard form. So vertex form is y equals a x minus h squared plus k. So you're looking for something that looks like that. Standard form is ax squared plus bx plus c. And factored form is going to be x minus a number with x minus another number. Or it could be plus, depending on whatever that number is. But there are your three forms of the quadratic, and you're just matching to see which one looks like vertex, standard, or factored form. All right, 34. Which of the following is a factor of 2x squared plus 5x minus 12? So first thing I notice is that I have this number in front of x squared. When that's the case, I need to go ahead and multiply my first and my last term, my a and my c. 2 times negative 12 is negative 24. From here, I'm going to set up my giant X, which organizes my thoughts. A times C is going to go on top, so that negative 24. B goes on the bottom, so 5. This is A, B, and C. I am trying to find two numbers that multiply to negative 24 and add to 5. So let's brainstorm. What times what gives you 24? Well, 2 and 12, 4 and 6, 3 and 8, and some combination is going to give me a positive 5. Now, since this needs to multiply to a negative 24, that means some of these numbers do have to be negative. So I can see that 5 and 3 is going to give me, 8 and 3 is going to give me a 5. If I were, what am I writing? If I were to subtract 8 minus 3, gives you 5. So 8 times negative 3 gives you negative 24. 8 plus negative 3 gives you that 5. From here, I'm going to rewrite my expression, and I'm going to split the middle. So instead of writing 5x, I'm going to write 8x minus 3x minus 12. And since I have 4 terms, I'm going to factor by grouping. So I'm going to group these terms together and look for the GCF of each group. So for my first group, what do they have in common? Well, they're both divisible by 2, and they both have x's. For my second group, they are both divisible by 3, but since my third term is negative, I need to actually take out the negative 3 instead of a positive 3. So I'm going to go ahead and factor out my GCF from each group. When I take out a 2x from 2x squared, that leaves me with x. 8x divided by 2x is 4. When I divide negative 3x by negative 3, that gives me x. Negative 12 divided by negative 3 is also 4. These two should always be the same. From there, I can get to my double bubbles, or my factors. I like to call them double bubbles. I have x plus 4, and what was in the front of my parentheses is my other factor. So I have x plus 4 times 2x minus 3, so which is a factor, 2x minus 3. All right, the next portion of Unit 6 is solving quadratic equations. So solve each equation, if necessary, round to the nearest tenth. So if I look at 35, I have 2x squared plus 8 equals 4. I notice right off the bat that I only have an x squared here. I don't have any x terms or anything like that. So I'm just going to solve this like I normally would solve an equation. So I'm going to subtract 8 from both sides. That leaves me with 2x squared equals 4 minus 8 is negative 4. Divide by 2. And I get x squared equals negative 2. Now, to undo a square, I need to square root. However, if you notice, you are taking the square root of a negative, which does not exist in the real number system. It is an imaginary number, which we will learn about in the future, but not in Algebra 1. Since we are taking the square root of a negative, doesn't exist. So this one has no solution. Number 36, I'm going to go with that same approach because I noticed that I just have an x squared. So I'm going to subtract 8 from both sides. 17 minus 8 is 9. So I have x squared equals 9. I'm going to go ahead and square root. Square root of 9 is 3. However, it is plus or minus 3 because if I were to square 3, that would give me 9. If I were to also square negative 3, that would also give me positive 9. So this gives you two answers, positive 3 and negative 3. Okay. 37 is set up as factors. So I'm going to use the zero product property, which tells me that I can set each factor equal to 0, and I can solve. For my first one, subtract 7 from both sides. I get x equals 7. For my second one, I'm going to add 5. So I have 4x equals 5, and divide by 4. So you get x equals 5/4. Number 38, I have a combination of x squared and x, but one thing I do notice is that they both have an x in common. So I'm going to start by factoring out the GCF. My GCF is x, so I can pull out an x from both of my terms. If I take out an x from x squared is x times x, that leaves me with x. And if I take out the x from 8x, that leaves me with 8. And once again, I have my factors, and the zero product property tells me that I can set each factor equal to 0 and solve. First one, x equals 0, you're done. Second one, subtract 8 from both sides, and you get x equals negative 8. For number 39, it is a trinomial. I instinctively start by trying to factor, because usually factoring is the easiest route to take if you're good with your factors. I'm trying to find two numbers that multiply to 30 and add to 13. That is 10 and 3. Since my a is 1, I can go ahead and use these two terms in my factors right away. You do not have to factor by grouping. It's a little shortcut, but it only works when a is 1. Sometimes a is not 1, like you can see with number 40. But from here, zero product property tells me I can set each factor equal to 0 and solve. So I get x equals negative 10. And x equals negative 3. Now, let's say you're not very good at factoring and you do not like to factor. You could use the quadratic formula for number 39. A is 1, B is 13, and C is 30. So you could use the quadratic formula if you wanted to. Number 40. I'm going to go ahead and see if I can factor it. So since I do have an a that's not 1, I need to multiply a and c. So 3 times negative 10 is negative 30. And my b goes on the bottom. So I'm trying to find two numbers that multiply to negative 30 and add to negative 11. I don't think those numbers exist. So this right here, unfortunately, is not factorable. That doesn't mean it's not solvable, because we do have another method in our toolbox, which is the quadratic formula. So I'm going to go ahead and write that down. So x equals negative b plus or minus square root of b squared minus 4ac all over 2 times a. I hope I don't run out of space. I'm going to go ahead and write down my a, b, and c. A is 3. B is negative 11, and C is negative 10. So I'm going to go ahead and put those numbers in the correct spots. Negative B means I'm taking the opposite of B, so that's going to give me a positive 11 plus or minus square root of B squared minus 4 times A times C all over 2 times A So I have 11 plus or minus, I'm going to figure out that radical in a second, all over 6. So in my calculator, I'm going to type this in exactly how it looks so I don't make any sort of computational errors. And that gives me 241 underneath my radical. Now I'm going to go ahead and take the square root of 241. And we'll go to the nearest tenth. It's about 15.5. Now in order to get my two solutions, I am going to go ahead and separate this to 11 plus 15.5 divided by 6, as well as 11 minus 15.5 divided by 6. So for this first one, 11 plus 15.5 is 26.5 divided by 6 is approximately 4.4. As you can see, I've run out of space. It's okay. For my second one, 11 minus 15.5 is negative 4.5 divided by 6. Oh, I've really run out of space. Is negative approximately 0.75. Oh, I had to squeeze it in at the bottom. All right, it's a good thing 41 doesn't take up that much space. So again, for number 40, I did have to use the quadratic formula because unfortunately it was not factorable. Even if it is factorable and you wanted to use the quadratic formula for 39, go ahead. You could also use the quadratic formula for 38 as well if you didn't recognize that you could factor out the GCF. For 38, if you were to use the quadratic formula, A would be 1 for 1x squared, B would be 8 for bx, and your constant would just be 0. And then you carefully plug it in and work through that process, and you would still end up with 0 and negative 8. All right, 41. Find the value of k such that each equation is true. So this value of k comes from completing the square. So essentially what this question is asking for is it is asking for whatever value this blank would be to give you this perfect square trinomial, which when you factor is x minus 6 squared. So you're completing the square. So I'm going to make a little note, completing the square. Now, how the heck do you complete the square? Well, I'm going to take half of b. So here's my b. So I'm going to take half of b and I'm going to square it. So half of b is negative 12 divided by 2, which is negative 6. Squared is 36. So that means k equals 36. All right, so that concludes the video for Unit 6 Quadratics in Standard Form.